Since January 2011, more than 10,000 improvised explosive devices, or IED events, have occurred in more than 112 countries. The ability to detect chemicals used in explosives can save our soldiers and civilians' lives. Dr. Chris Field and scientists at the Naval Research Laboratory have developed a patent-pending process using silicon for a sensor that may revolutionize the way we look at trace chemical detection. It's called SynVapor.
Detecting IEDs in the battlefield or explosives at airports is a complex problem because it's a trace chemical detection problem. And what that really means is that IEDs and the compounds that we're interested in don't really want to be in the gas phase. And that's where we need them to be in order to do our detection. So they need to be up in the air. But these are easily masked or overshadowed by a more abundant compound, such as perfume or diesel exhaust.
DOGs and laboratory-grade equipment are the current state-of-the-art for trace chemical detection, but both are expensive and require a trained professional to handle. The sensors that Dr. Field is working on are an example of nanotechnology.
Nanoscale is 1 × 10⁻⁹ meters is sort of the scientific definition. Another way of putting it is, let's assume that the diameter of a human hair is 100 microns. So you can take the diameter of human hair, cut it down, and you look at the cross-sectional area. We can fit 1 million of our nanowires in the cross-sectional area of a single human hair. So what's really needed for the soldier and the warfighter and at airports is small, portable, lightweight, low power, low overhead sensors that you can give to everybody and distribute them across the globe.
The sensors are in the early stages of development, but the technology has demonstrated detection capability on the parts per billion level of sensitivity.
SynVapor stands for silicon nanowires and a vertical array with a porous electrode. SynVapor is unique and different from other technologies out there in that it's a 3D architecture. So we're maximizing the surface area, so we're maximizing our sensing capabilities within our architecture. With our technology, we've been able to demonstrate parts per billion, and just recently we're able to demonstrate parts per trillion detection of chemical compounds. So the first part in solving trace chemical detection as a problem for IED detection is getting that sensitivity, is being able to detect and operate in the parts per trillion to parts per billion range. This is why we're very excited about the SynVapor architecture, because we've been able to demonstrate that level of sensitivity. The next big hurdle, which is where we're at, is selectivity. Fortunately, since we're using silicon and we have that entire history of functionalizing and changing silicon structure, we can utilize that from the semiconducting industry to hopefully advance that. Combine that with some of the NRL scientists and the facilities that we have here at NRL, and we're very excited and very confident that we can accomplish and get over that last hurdle to transition this technology to the warfighter and also to the consumer.
What does the future look like for the SynVapor sensor?
The goal of this sort of project is to have a small field deployable distributed sensor on the same form factor as a cell phone. This would be something akin to the Star Trek tricorder is what we're trying for, so that everybody can be able to do chemical detection with their cell phone. We could give that to every soldier in the field. So now every soldier becomes a point detector out in the field and can identify IEDs and do that without having to be very close to them, which is also the problem. And then this could also be used to supplement DOGs and also help in airport security. So one way of doing airport security in the future, if you had a sensor that demonstrated the necessary sensitivity and selectivity, like the SynVapor sensor is going towards, then you could distribute that throughout the entire airport and have a checkpoint-free airport security system where you can map in real time the chemical plumes around every individual in the airport.
Making air travel a relaxed, pleasant experience with no lines at the airport, one could only hope. There is a lot of research yet to do on SynVapor before these sensors are used in our cell phones to detect the environment around us, but it's an exciting idea. NRL Science, solving the challenges of tomorrow.